Welcome to Unit 5. This is Section 1, and today we're going to start off by talking about solving systems of linear equations. If you recall from our previous unit, we looked a lot at writing equations of lines and linear functions and also their graphs. Now we are going to graph a system of linear equations and find its solution. First of all, a system of linear equations is simply a set of two or more linear equations using the same variables, and a solution to a system of linear equations is simply an ordered pair that satisfies both equations or all equations in the system. In other words, it will make true statements when you substitute in that ordered pair to both of those equations. And that's one of our key concepts. We are going to learn how to find a solution to a system, both using algebra and using our graphing calculator. So in order to determine if a certain ordered pair is a solution, we're simply going to plug that ordered pair in, the values for x and y, into both equations, and we're going to simplify it and determine if it makes a true statement. If it makes a true statement, then we'd say it's a solution to the system, and if it doesn't make a true statement, then it's not a solution. Let's see what we mean here in example 1. It says tell whether the ordered pair is a solution to the system of linear equations. The ordered pair they give us is 3, 1. So that means my x value is 3, my y value is 1. So my key up above and my key concept said substitute those values in for x and y. So I'll have 3 plus 1 and determine if it makes a true statement. Well, yes, 3 plus 1 does equal 4. So my first equation forms a true statement. The next equation would be 2 times my x value, that's 2 times 3, minus 1, and my question here is that equal to 5? Well, yes, 6 minus 1 does equal 5. So both of these statements are true for the ordered pair 3, 1. That means 3, 1 is a solution to the system. In my system here of linear equations are the two equations that I started off with. Sometimes you'll see them written in this brace here that looks like a face. All right, example 2 says tell whether the ordered pair is a solution to the system of linear equations. The ordered pair they give us is 1, 2. That means we're going to substitute 1 in for x and 2 in for y and determine if they make true statements. So we have 1 minus 2, and my question here is that equal to negative 2? Well, no, that makes a false statement. This is negative 1 equals negative 2. No, that's not true. Now, we don't really need to go any further, but let's just go further one more step here and determine if that next statement is true. We'd have 2 times 1 plus 2 more. Well, that gives me well, the question is, does that equal 5? And that gives me 4 is equal to 5. No, well, 4 is not equal to 5. So these are both false statements. And when we get false statements like that, and you only need one false statement, you don't need two false statements, you just need one false statement, we know that the ordered pair 1, 2 is not a solution to that system. All right. Let's move on and let's talk about looking for solutions on the xy plane. It says use the graph of this to solve the system of linear equations and then check your solution. Well, solutions are the intersection point. All right, this is where our graphs are going to intersect and overlap and have that point in common. So let's take a look and see if our graph that we can determine what that intersection point is. So here's one function. It looks like it slopes up and to the right, and here's another function, linear equation that slopes down and to the right. And it looks like they intersect right here, and that this is the ordered pair negative 1 and down 1, 2, 3. So that's negative 1, negative 3. Now that's our guess as to that's our solution, and let's just figure out if that is our correct solution by substituting x is equal to negative 1 and y is equal to negative 3 into our two equations. So let's take this top equation first. We've got negative 1 minus 2 times a negative 3, and my question here is, does that equal 5? So this is kind of a tricky statement now. Be careful. You have a multiplication that you need to do first. Negative 2 times a negative 3 is a positive 6. This is negative 1 plus 6 is equal to 5. And yeah, that's true. Negative 1 plus 6 is equal to 5. So that forms a true statement. And our next one here says 2 times our x value plus our y value should be equal to -5. So let's check that out. We got -2 plus a -3 is equal to -5. Yeah, that's true too. So our statements are both true, and that means the intersection point here of -1, -3 is the solution to our system. And again, just highlighting this fact, this should be something that you maybe jot down on your notes. The solutions to systems happen at the intersection points. So look at the graph, find the intersection point, and it's that ordered pair that will be the solution to your system. All right, let's crack open those graphing calculators. This next one, we're going to graph our 2 linear equations to solve the system by graphing. So first of all, let's do it by hand. These are both in slope-intercept form. I have a slope of 1/4, and I've got a y-intercept of +3. So we're going to plot that here, +3, and rise 1 and run 4. Rise 1 and run 4, and then there's our line. We're going to draw a line as best we can through those 3 points here, and there's one line. Okay, the next one has a slope of 3/4 and a y-intercept of +5. All right, so here's +5, and on our y-axis we're going to rise 3, 1, 2, 3, and run 1, 2, 3, 4. Rise 3 more, and then run 1, 2, 3, 4 again, right here. All right, and we're going to draw a line again through those 3 points as best we can. And yeah, we're going to take a guess. We're going to take a guess that our intersection point is right here at -4, +2. Now, we're not quite sure, but this is where our calculator comes in nice and handy. So grab your graphing calculator, and let's take a look at graphing these 2 linear equations. So go ahead and turn your calculator on and go up here to your y equals, and we are going to enter in our 2 equations. So our first one here was 1/4 x, and your x variable right here next to your alpha key, +3. There's our first equation. Let's go down to our second equation, which is 3/4. Now you can also enter that in as a decimal if you prefer to do a decimal, 0.75. All right, once we have our 2 equations, we are going to now look at the graph of that. So we'll press graph over here on the top right hand side. And if your graph kind of looks like mine, where you can't really see it very well, there's a way to get back to your standard zoom viewing window, and that's going to happen by pressing zoom up here at the top row, and then you're going to go down to number 6, the standard zoom, and you can just press number 6 on your keyboard. There we go. Now we get a better graph, and we can see that these 2 intersect, yeah, right here. It looks like -4, 2. Now, in order to be exact, our calculator can tell us. We're going to go to the second function. You're going to press second function and trace. That takes you to this calculate menu. And you can see here one of our options is intersect. So let's go down to number 5 and press intersect. And our calculator wants us to know which 2 lines or curves do we want to find the intersection point for. So while the cursor is on one of them, press enter. And you'll notice the cursor jumps up to the other one, asks you for the second curve. Go ahead and press enter. And then the third one is always a guess. They want you to place the cursor as close to that intersection point as possible. So we're just going to move that cursor, just a little bit to the left there, and press enter again. And there it is, -4, 2. All right, so we've got our intersection point here is at -4, 2, and we said up above that your intersection points are your solutions. So this would be the solution to the system. If I were to plug -4 in for x and 2 in for y, I would make 2 true statements. All right, in our final example for today, we're going to solve the graph by, we're going to solve the system by graphing. And now you'll notice that they're not in y equals mx plus b form. They're not in that nice graphing form. So we can move them easily into that y equals mx plus b, which is get y by itself. So this first equation, we're going to subtract over our 2x. That gives me 2y equals -2x plus 2. Notice that I put that 2x in front of the 2 there. Now I got to divide off the 2. All right, so that gives me y equals, and I got to divide both terms by that 2. That gives me negative x plus 1. So there's one graph. And our next one here, we have 3x minus 3y equals 21. So we're going to subtract over that 3x. That gives me negative 3y is equal to negative 3x plus 21. And divide both sides by negative 3. All right, that gives me y equals negative 3 divided by negative 3 is a positive x. And then a positive 21 divided by negative 3 is a negative 7. All right, so here is the system that we want to graph. Y equals negative x plus 1 and y equals positive x minus 7. Go ahead and use your graphing calculators and graph those two linear equations, and we'll talk about the solution tomorrow in class.